Welcome back to Teaching Technology. Today, we are writing a smart contract in Ubuntu with Hardhat. Now, what is Hardhat? Hardhat is a way to write smart contracts in Solidity. It works wonders to make your code more efficient as you write your smart contract, and it contrasts with the truffle smart contract way of writing smart contracts. Before I move on, today's tutorial will be just creating a basic token. I highly advise you to more understand the template, how Hardhat works, as well as how the code is actually built. My GitHub will be in the description, as I have a lot of smart contracts that build things like NFTs and very similar stuff that can all be templated. The point is to template your code and then build on top of it. Most people use Open Zeppelin, which is a package that deploys a multiplicity of smart contracts that you can use. This is really just understanding Hardhat as well as getting started with Hardhat and React. In future videos, we will make more complex applications, but this one is just understanding how Hardhat actually works, understanding the code, deploying a live project, working with APIs and API keys, working with MetaMask, etc. Our initial setup, so we're going to use Ubuntu. Obviously, if you don't have Node, the description will have those commands for downloading Node on your Ubuntu server. Actually, you know what? Let's just do that. Actually, let's just go here to the Hardhat guide itself. And setting up your environment. And these are the commands right here. Oh, these are the commands right here. Let's do this instead. And by the way, let me know in the comments how you feel about the PowerPoints, because I can make them all available for everyone if you like them. So once you have your node installed, you're going to want to run npm -- save dev hardhat in your project folder. And everything can be found on the actual Hardhat website itself. Like I said, this project is just about teaching you the basics of Hardhat. then in future videos, we will actually integrate our TypeScript and our React build skills with blockchain and now our Solidity build skills, because in this industry, the highest paying jobs are the ones of people that have a full stack skill set, not necessarily full stack development as far as everything, which definitely is important, but if you want to be a blockchain developer, then it's really good to have a fundamental understanding of React or some kind of framework, as well as a fundamental understanding of Solidity and Hardhat. And it's the same thing with if you want to be a full stack developer, right? Your best bet, and then you're going to run on npx Hardhat here. Your best bet would be, and we're going to choose create an empty hardhat config.js. And remember this GitHub right here, as they have a template code that you can clone. And in this tutorial, you can see here, we're going to download this at Nopic Foundation Hardhat Toolbox. That's just going to make it easier to work with. So let's paste this command. But yeah, if you want to be a Web 2 developer, then it's always good to have a fundamental understanding of things like, things like databases, understanding SQL, having a front-end language, and then, understanding how to build servers or something like that. But as they say, a jack of all trades, master of none. So it's really good to not know a bunch of languages, but to be really, really good at one language. And then you might ask yourself, well, then why Solidity? Well, because there's just so many things that Solidity hasn't penetrated yet. I mean, you look at the real estate industry. There's been this big buzz about NFTs. Everyone knows about NFTs. Everybody wants to build an NFT. NFTs can have real utility in industries like real estate. You have supply chain, retail, e-commerce, the automotive industry, the gaming industry, again with NFTs. And just having this fundamental understanding, it will be a lot easier to work with frameworks like OpenZeppelin, etc. So the next thing we're going to do, let's open our code. And unlike with Truffle, you can just have it automatically have your folder, have it set up where you have your contracts, your testing, and your migrations folder. With Hardhat, it doesn't work that way. But we do get this right here that denotes our Solidity version, which I'll get to in a second. Oh, and the one download that I forgot to do was this npm install save dev at Nomic Foundation Hardhat Toolbox. Wait, never mind. We got it. But we got to put it in our package.json folder. I'm sorry, in our Hardhat config. And there we go. Now let's make some folders. Let's make a directory called contracts. Let's make a directory called scripts. And let's make a directory called test. And now, and we're going to build a token today, but before we do that, actually, you know what, the next thing we're going to do is let's work with OpenZeppelin. I do want to write most of the code out, but I just want to show OpenZeppelin because I think having a fundamental understanding of OpenZeppelin is important. In this industry, almost everything is written with OpenZeppelin. NFTs, contracts, ERC20 contracts, ERC721 contracts. Basically, OpenZeppelin features a stable API, which means that your contracts won't break unexpectedly when upgrading to a newer minor version. An alternative to input, blah, blah, blah. And this is big for building NFTs. And there we go. And let's CD into contracts. And let's create a file called for now we'll just do YouTube token. I think in later videos, as we start to build our front end, we'll start to see what we want. So I think what we're going to build on our front end is just similarly to what we had in our last video with React. We'll just have it be a video uploading service, and the token they transfer will be donation. Okay, so let's get in our code. So we have our YouTube token.sol. So the first thing that we're going to do, and this is for every single contract, is this SVDX license. You don't get an error, but because you're doing it in VS Code, it will give you a minor warning. So I like to just avoid it. And the next thing that we're going to do is we're going to denounce our Pragma Solidity version. And you get that from this Hardhat config right here. So we're going to choose 817. And because we use that caret, we don't have to be at the best one, because it changes over time. That's why it's always good to have that caret. So because we imported this Open Zeppelin right here, or because we downloaded this Open Zeppelin right here, it gives us these contracts. Right, so if we go to token and we go to ERC20, what this does is it gives us a pre-built interface for how to build an ERC20 token. And we just fill in the blanks of what we want our token name to be, our total supply, the owner, the balances, etc. Because all of these functions are the building blocks of a token. Same thing here with an ERC 721, which is what an NFT is. See, today we're going to be actually building our token because I want you to get a fundamental understanding of how to write these functions, etc. But normally it's common practice to have a lot of your work be done with Open Zeppelin. This is an ERC 777. Support for ERC20 is included in this contract as specified by the EIP. Both the ERC 777 and the ERC20 interfaces can be safely used when interacting with it. That's why I want to build an ERC20, because even though we're not in the bull run and people aren't building ERC20 tokens, it's good to have a fundamental understanding of how to build an ERC20 token, because when you get to starting to build things like ERC 777 tokens, which are essentially tokens, especially in the gaming industry, as I mentioned before, that are tokens that work with both. Oh no, I'm sorry, that was the ERC 1155. So ERC 777 are tokens that have support for ERC20 tokens included in the token itself. So it's a token where you can interact with both an ERC20 as well as an ERC 777. And then here is where we have an ERC 1155. And this is what I was referring to earlier, where you have a token that works with both an NFT as well as takes in ERC20 tokens. So in this industry, because you obviously have a lot of people building NFTs and building ERC 777s, it's common practice to have a fundamental understanding of what a token actually is and how to build one first. And especially people that want to be entrepreneurial, it's a good idea to have an understanding of how to build a token. But that is Open Zeppelin. some of the other stuff that it has is it has structs. This is a function is contract. It relies on extra code length, which returns a 0 for contracts in construction. Says the code is only stored at the end of the constructor execution. So this would work for a bunch of contracts being run. And this gives you for arrays. This is counters. So this could help with, maybe, you have some kind of contract, maybe like an IPO, or sorry, an ICO. Those counters could help a lot. Then you have math. Obviously, safe math is something that people use a lot. It helps with math again. With an ICO, this could help, or really any kind of math in a contract, maybe with transfers, etc. This is something that we could add. This gives you another interface. This escrow, this contract and derived escrow should be a standalone contract that only interacts with the contract that initiated it. The way it guarantees that all Ether will be handled with the escrow rules. So this could help with maybe a DAO. The point of me showing all this is because all of these things are very, very fundamental when it comes to working with contracts and getting a job, and just being, successful in this industry. Cross-chain is another big thing, especially if you're working with Polygon and maybe you want to have, interaction with Ethereum, or, provides information for building cross-chain aware contracts. This abstract provides accessors and modifiers to control the execution flow and treat cross-chain messages. So that's something that really helps a lot, especially if you want to build a Polygon contract. And you got these timers. This helps a lot if you have a contract that depends on years and time or deadlines, etc. So all of these things are very, very fundamental and key. Trying to think if there's any contract that maybe I could add to this. I will do this security and I'll do this reentrancy guard, because this is a good security protocol. So we're going to import this into our token. So what we're going to do is we're going to import node modules. At Open Zeppelin. /contracts. /security /reentrancy guard. Gotta get the imports right. Opens up and then take it manually. And then move it into coinsurance. Okay. So the first thing that we're going to do is we're going to define the name of our token. And I don't want to name it YouTube token. Again, I highly advise you to just take this as a template, understanding, okay, my token has to have a name, it has to have this, it has to have that. Don't just copy the code word for word. Let's do a random name generator. This is going to decide what our website is going to be called, what our token is going to be called, everything. Alright, it's going to be called... No, I don't want to name it Jennifer token. That's weird. Here we go. Dove. So we're going to call it Dove token. So the next thing that your token has to have is a total supply. So we'll just set it here. This arbitrary value. Then you need to have your store of account. So we'll just do address public owner. Just define that. Next thing you need to do is create a mapping. So basically a mapping is just key value pairs. This is a way that we can get balances, especially as more people want to get our token. We need an easy way for them to access their balance. Next thing we have is we have an event for a transfer. A lot of tokens and contracts are a lot more complicated than this. This will really just be our biggest functionality. But again, understanding these fundamentals are key to starting to write complicated smart contracts. So here we have a from address, a to address, and a value amount. Now let's create a constructor. Here in our constructor, we're basically just going to define the message sender and the total supply. This is basically just defining that our balances of the message sender equals the total supply. Basically, in common speak, is just saying that the total supply of the amount of the person sending the tokens is what their balance is. And then you just want to define who the owner is. So let's create a function. This is a function for transfer. And we have our address 2 and our UNT 256 amount. This is an external function. Functions have 4 different kinds of, I guess you could say, view types, or access, or I guess access types. The first one is public. Public basically means that anyone can access it within the contract. So any function can call it, any other function can call it. External means that it's called from somewhere else. Internal and private are the other two. Private functions are called within the function itself, within the contract itself. And internal contracts are happening within only the function, and they're also private. So it's public, private, external, and internal. And remember that call that we did here at the top? Well, we're just going to call non-reentrant. I think that's what it is. Let me make sure. Oh, I spelled it wrong. Oh, it's actually now non-reentrant before. And that is actually how we call our imported Open Zeppelin into a function. So we call it like this. So we call the function name that we're using. But it's to not repeat. That's why you call it like non-reentrant after and non-reentrant before. And in that, we're going to do require statement. Basically, is at the balance of the message.sender. That's what this means. Similar to using like dot notation in JavaScript. You know, saying that this balance right here, this balance of message.sender is greater than equal to the amount. And then basically it's giving a return type, just saying not enough tokens. And here's a function that we can do, or I'm sorry, not a function, a call that we can do from the Hardhat library that we cannot do in Truffle, and that's a console.sol. Essentially, it's a way that we can console.log, like we can do in JavaScript, elements of our function. This really helps us, especially when we want to build things with our front end. And let's use that call. We can actually console.log this is saying identifier not found or not unique. This basically is giving a message to the console. Let's just say sending from, and this will actually console.log whoever's whoever that actual sender is. So whoever that actual to address is. The from address is. And then we have this to address. And similar like to we do in JavaScript. To for and then we have our variables. So message sender to address and the amount. So we still got this pesky bug. Identified or not found or not unique. I found out my error. It was because you have to use this is keyword and you have to actually call it like so. Then we should be good. So after that console.log, we'll actually do the transfer itself. So balances message.sender. Minus equals some amount. And then we got the to address. Now, the final thing we're going to do is remember this event right here on line 11? Well, we're actually going to use this emit keyword to call that event. And then the three variables that we've been working with this whole entire time, this message.sender, this to address, and this amount value are all going to be called. And that's the end of that function. So the next function that we're going to do is we're actually going to get the balance of the contract. This will be an external as well. Then it's a view. And it's going to return a uint 256. And this view keyword, it basically means that there's action that's going to be taken. There's the view and the pure keyword. The pure keyword would mean that there's really no action being taken outside of the function. And now that we have our two functions written, okay, so the next thing that we're going to do is we're actually going to, let's clear this, is that we're actually going to compile our smart contract. Oop, 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 oop. It's because I'm not, didn't mean to do that. It's because I wasn't in our project. So I'm going to CD in the Hardhat tutorial. Let's clear that. And then we'll run that compile command. It's going to say nothing to compile for me because I've already compiled it, but for you it should say compiling 2 files. So the next thing that we're going to do is we're going to set up our deploy, and then we're going to actually deploy it to a testnet. So let's do that. So in our, see how we have some more files now that we've deployed it. So we're going to cd into scripts, and let's create a file called deploy.js, and let's traverse to it. Some like to test first, some like to deploy first. I like to deploy first and then test later. We will do testing. As you can see, we have this test folder right here. Now in our deploy function, in our deploy file, let's create our function. So const deployer, we're going to use that await keyword. Ethers.getSigners. That's common practice. We're going to console.log a couple things. We're going to say deploying contract with account, and we're going to do deployer.address. We're going to console.log our account balance as well. Wrapping it in another await keyword. We're going to say await deployer dot get balance, the function that we ran. We're going to say, and we're going to make that a string. Now we're going to define the name of our contract. So for ours, we called it YouTube token. We're going to say await ethers dot get contract factory, not at, which is standard practice for getting the contract. And then we're going to name the contract name YouTube token. Now we're going to define const token equals await. We're going to define that YouTube token dot deploy. And then we're going to console.log our token address. And we're going to say token.address. And then now we're going to do a catch block for any errors. console.error. Oop. Oh, and then we'll do a process.exit 1. And now we have our deploy file. But before we can do anything, we're going to sign up to Alchemy. And now I'm in Alchemy. So let's name it YouTube token. I'm in our Alchemy dashboard. And because everything else is deprecated, we're going to have to go with Gorelli. Let's see if I have any Gorelli actually. And you can run your contract with Polygon Mumbai. I did that in the past. But I think I want to do Gorelli on this one. Which means I'm going to have to get some Gorelli token. Here we go, Gorelli testnet. Yeah, I'm going to have to get some Gorelli ETH. So in Google, we'll go Gorelli testnet faucet, and we'll get some testnet ETH. And you'll get 0.2 Gorelli ETH a day. So we're going to copy and paste our address. Well, it's funny how you have to go to Alchemy, so we already have our Alchemy set up. And we're going to paste in our Gorelli address. Send me ETH. And hello friend, will you spend that Gorelli ETH on your pet or your next DApp? And we're getting our Gorelli ETH as it's loading. So now we'll go back to Alchemy and let's create our app. Let's install the Alchemy's SDK. I feel like it will make it easier for us, so we're going to do that next. And while that's installing, let's create our app. And our app is created. And let's click on it. And now we're in our app. And let's just make sure we have our Gorelli. And we have our Gorelli right there. So let's view our key. And we're going to copy that API key. And we'll traverse to our Hardhat config file. And now we're going to create a variable here. We're going to call it const alchemy key. And we're going to paste it. And we're also going to get the Gorelli, if I can spell it. We're going to get our Gorelli private key as well. And how we do that is that we're going to go to our MetaMask right here. We're going to click on these, where is it? Nope. Click on these three dots. Is it account details? Export private key. Type our MetaMask password. And this is our private key right here. And we're going to paste that in. So as you can see here, we got our alchemy key and we got our Gorelli private key. So the next thing that we're going to do is in alchemy itself, we're going to get this ETH Gorelli. Trying to find it. This HTTP. /v2. Here we go. Have this HTTPS. We got networks. Gorelli. URL. Paste in that URL. Alchemy key. And then we have accounts. And we're going to do our Gorelli key, Gorelli private key. And we're ready for deployment. So let's run our deploy command. So npx hardhat run scripts /deploy .js -- network Gorelli. Deploying contract with account balance, token address, bam, bam, bam. Now we're going to test our contract. And then we're going to move on to running the front end. So in our test folder, let's cd into test. And we're going to make a file called YouTube token.js. And now in our test folder, let me just break this down really quickly, and we can move on to our front end. So the first thing that we did was we added a deploy token fixture. And with all disclosure, I did pull this from the actual testing project itself from the boilerplate, just because it's easier to explain and it's good to have. So to deploy our contract, we will have to call token.deploy and wait for it to be deployed. There's a couple things that we will change though. We will change this to YouTube token. Because we want to have it the same name as we have in line 7 in our deploy here. So we have our YouTube token there. And that's really the only change. Everything else is good to go. So let's run npx hardhat test. Oh, token is not defined. So we have to change it to YouTube token everywhere that it is. And it's obviously going to be in every single contract. I mean, in every single test. That didn't help. Line 27. I think that's the only spot. Transactions. It should transfer tokens between accounts, async function, const hardhat token, owner, bam, bam, bam. It should be good to go. So we have 3 passing, 2 failing. The only ones that are failing are the total supply and should fail if sender doesn't have enough tokens. So we're going to comment those out. we'll comment that one out. And we'll comment the doesn't have enough tokens. And now that we commented those out, we have the ones that pass running. So the next thing that we're going to do, now that we have our full contract running and deployed, so the final step that we have to do is that we have to upload our code to GitHub utilizing a personal access token. And the commands are here. So the first thing that we're going to do is we're going to initialize Git. Then we're going to do git remote add origin master. Oh, I'm sorry. Not add origin master, just origin. And we'll just call it YouTube Hardhat tutorial. And let's create the repo. Paste it. Then we'll run the command git config user.name. And then we'll do git config user.email. Then we'll do git add period and git commit -m. Just call it initial commit, and bam. And then we want to create our key. And to do that, I already have my key created, but just want to show you how that's done. So you go to developer settings, personal access tokens, and I'd go with classic. So you can see I have my token right here, YouTube token. You want to generate a new token. Click on repo. We'll just have it for, we'll just create another one. I'm not going to use it, that's why I made it no expiration. Repo, just made it ABC. And you want to click on that generate token. Then you're going to get this right here, and you're going to paste it. As this is downloading, and I would just create like a little txt for you and paste it in there, put it in your git ignore, just so that you have it for future reference. And you want to put in that pat.txt file right here. And everything's starting up. And you got that TXT. And you just want to paste that in there, like so. I'm going to delete that key because I don't need it. Actually, you know what? I'll use it. I'll use it for this example. So we want to do get push origin master. We're going to put our username in there. And then we're going to paste our password token. And if you go to our repos, you'll see that our repo has been updated just now. And our code's good to go. And that is how to create a basic token with Hardhat. Again, like I stated before, it's really, really common practice to template this, understand how everything works, so that you can build on top of my code. Thank you, and this has been Teaching Technology.